Alright, there's one more thing I have to tell you in regards to significant figures. This is something you're going to encounter when adding and subtracting, but specifically when adding and subtracting numbers that have exponents associated with them. If the numbers that you have possess different exponents, then you're kind of comparing apples to oranges. And you know that you're adding and subtracting, so you may recall, okay, we're going to look at the number of decimal places. And you might say the first one has 1 decimal place, the next one has 4 decimal places, this one has 2, and that one has 3. And if you didn't have the exponents, that would be completely correct. But the point is that the exponents are not the same, so you are comparing apples to oranges. And what you need to do is to bring the exponent to the same value in order to actually make the comparison in regards to the decimal place. So yeah, the description that I just gave you right now, 1 decimal, 4, 3, and 3 decimal places, is actually incorrect. What we need to do is change the exponents such that we end up with the same the same level ground in terms of the comparison. Alright, so what you need to keep in mind is that if you want to change the exponent to make it greater, you're going to be moving the decimal place to the left. And if you want to decrease the value of the exponent, you're going to be moving the decimal place to the right. So, and then you could think of this as ill doctor, right? That will be your acronym, yeah? This is who's teaching your class? The ill doctor, yeah? All right, okay. Hopefully that's not how you refer to me, but then again, I put it out there, so my fault. All right, so there's a few possibilities of what you can do. You could change everything to 10 to the negative 2. You could change everything to 10 to the negative 1. You could change everything to 10 to the first. You could even change everything to 10 to the third. But as you'll see in a second, for some circumstances, making the exponent larger and larger may actually be a bad idea. I'll get to that in a little bit. But in order to change the numbers to these various exponents, what you have to do is say, okay, what's happened to the exponent? And for the first number, 10 to the negative second is literally what you have, so you don't change anything. It's literally the number as is. But if you want to change that to 10 to the negative 1, the number is actually becoming greater, right? Because 10 to the negative 2 is greater than 10 to the negative 1. Because the number is getting greater, you have to move the decimal place 1 unit to the left. Now, if you make the number go even greater than that, right, so you go up to plus 1, the original being negative 2, to go to plus 1, you have to go from negative 2 to negative 1, from negative 1 to 0, and from 0 to positive 1. So that's a change of 3 orders of magnitude. And as a result, you're going to move the decimal place from in front of the 1 3 units to the left. Alright, so you'll have 0.0013, and if you count this starting from the 1, you go 1, 2, and 3 units to the left. Same idea for all these numbers. The next one is 10 to the positive third. So to go to 10 to the negative 2, you are going to have to decrease it from 3 to 2, from 2 to 1, from 1 to 0, from 0 to negative 1, and from negative 1 to negative 2. That's a change of 5. So you're going to have to move the decimal place 5 units to the right. So you'll move it 1, 2, 3, 4, and then 1 extra unit, which will basically introduce this extra 0. For the next number, you'll only go up to the 3, so you stop at the 3 in terms of moving the decimal, right? Since you only have to move it 4 units to the right. And if you're going up to 10 to the first, then you only need to move it 1 and 2 units to the right, so you have 2.83. Okay, let's take a look at the next number, 10 to the negative 1. If you change it to 10 to the negative 2, that's a difference of 1 for the exponent. So you'll be moving that exponent 1 unit to the left. So now you have, 1 unit to the right, so you'll have 52.3. If you change it to 10 to the negative 1, well, technically you didn't change it because that's literally what you started with, so this is just 5.23. If you want to change it to 10 to the first, then you're going to have to move the decimal 2 places to the left. Okay? Now the last one, we have 10 to the first for the number. If we want to change that to 10 to the negative 2, we change 1 to 0, 0 to -1, -1 to -2. That's 3 overall changes. So we're going to be moving the decimal place 3 units to the right, in which case we move this 1, 2, and 3. You're dealing with 781. If you want to go only up to -1, then you'll move it only by 2 units, so 1 and 2. This will be 78.1. And if you want to go up to 10 to the first, well, that's literally what you started with, so that you just copy down the number as is. Alright, now that all the exponents are the same, you can finally look at the number of decimal places. And looking at the first set of numbers, you have 1 decimal place on the first one, 0 decimal places on the next number, 1 decimal place on the third number, and 0 decimal places on the last number. So technically your answer has to have 0 decimal places. So when you carry out the conversion, we'll see what happens. Now similar idea here. 2 decimal places on the first, 0 decimal places on the second number, 2 decimal places on the third number, 1 decimal place on the fourth. And for this last row, we have 4 decimal places, 2 decimal places, 4 decimal places, and 3 decimal places. Alright, if you carry out the numbers, the actual calculations, here it's actually a little simpler than you might think. Since all the exponents are the same, you could simply say 1.3 plus 2830 minus 52.3 minus 781. And whatever answer you get, all you have to do is multiply that by 10 to the -2. Same idea here. Whatever answer you get upon adding the numbers in front of the exponent, multiply by 10 to -1. And whatever answer you get here, multiply by 10 to the first. So when you perform that in your calculation, keep in mind that for the first thing, we are predicting to have no decimal places. Same idea for the second one. The least number of decimal places is 0. And over here, the least number of decimal places is 2. So we want to have 2 decimal places on this last answer. Alright, now carry out the calculation. You're going to find out the values to be as follows. 1998, 199.8, 1.998. Alright, so you want to have no decimal places, so you basically keep the 1998 since that doesn't have any decimal places. Over here, you want to have no decimal places, so that means that you have to get rid of the 0.8. Since that number is greater than 5, you're going to raise up the 199 to 200th. And same idea right here, you only want 2 decimal places. Since the number after the first 9, since the number after the second 9, which is the second decimal place, is greater than 5, right? So the 8 is greater than 5. We're going to raise up the 1.99 to 2.00. And the one thing you realize is that the numbers for the second and the third row are slightly different than the first. And the reason why is because by changing the number from 10 to the positive 3 to 10 to the -2, you had such a huge change in the exponent that you ended up introducing a 0 that wasn't there to begin with. So by doing that, you automatically messed yourself up. So the point is that when changing the exponents, don't change the exponent from a high value to a very low value, because you might end up introducing zeros that weren't there to begin with. And another thing that I'll tell you is that even though we went with the exponents present in there, another thing that you can do, and it's probably the thing that you're going to end up doing throughout, is to change the numbers to 10 to the 0th power, because anything raised to the 0th power is equal to 1. And so you could literally get rid of the exponents altogether. 10 to the -2 to be turned into 10 to the 0. Since you're increasing the exponent, you will have to move the decimal place 2 units to the left. So instead of 1.3, you'll have 0.013, right? 2 units to the left. This one that is 10 to the third, you will have to decrease it to 10 to the 0. So move the decimal 3 units to the right. So you end up with 28.3. Next number, to turn 10 to -0 to 10 to -1 to 0, you have to move the decimal place 1 unit to the left. And this one, to turn it into 10 to the 0, you'll have to move the decimal 1 unit to the right. Alright, so 10 to the 0 being 1 gets rid of the entire exponent, and you end up with the simple numbers here. And here you do the same thing. You look at the fact that you have 3 decimal places on the first number, 1 decimal place on the second, 3 on the third, and 2 on the last number. So carry out the calculation, you will end up with only one decimal place, in which case your answer is 19.98. One decimal place says that you stop at the 9, the second 9, and the number after that is greater than 5, so you basically round that up to 20.0, and once again you end up with the same answer. So hopefully this gives you the whole picture of how to go about looking at the number of decimal places when you're adding and subtracting exponents. Be careful with that. The second thing to tell you is that if I give you a number and I explicitly tell you that the number is coming from a measurement, then you will have to count it as having the number of significant figures that you see in the number. Don't treat it as being an exact number, even if you don't have that decimal point present. Um, all right, so I'll stop this video right now, and I'll see you in the next video.